Hello children, here's your video on inverse variation. So an inverse variation is basically the opposite, okay, the opposite of a direct variation. So an inverse variation is a relation or function that can be represented by the equation x times y equals k, where k is the constant of variation again, or in other words, y equals k over x. So in an inverse variation, the difference between direct and inverse, the fundamental difference, is that in an inverse variation, okay, as x increases, y instead of increasing, y decreases. So instead of as x increases, y increases, it's as x increases, y decreases. And you can see that here in this equation. Let's think about it just for a minute. If k is staying constant, and this x is getting bigger and bigger, the quotient k divided by x is going to get smaller. Think if k is a pizza and x is the number of pieces we're slicing them into, the bigger x is, the smaller the pieces are going to be, y. And here's a good example. The time it takes to arrive at your destination varies inversely with the rate at which you travel. So the faster you drive, the less time it takes to get there. Hold on, let me fix that. The faster you drive. So the faster you drive, the faster you drive, the less time it takes to arrive. The faster you drive, the less time it takes to arrive. Something I'm thinking about in preparation for driving to Connecticut for Thanksgiving. Now, the faster you drive, the less time it takes to get there. However, you could, of course, get caught speeding, in which case you've added an unpleasant extra, probably half hour to your trip, getting pulled over for a speeding ticket. But you understand the point of an inverse variation. One goes up, the other goes down. Let's use that equation that we just learned, y equals k over x, and let's answer this problem here. Y varies inversely with x. If y is 30, when x is 4, they wanted us to find k. So that's the first thing we're going to do is find k. So I'm going to take this formula, y equals k over x, and we're going to put in 30 for y, k stays k, and we're going to put in a 4 for x. Solve for k. Okay, so now we want to solve for k. Now how do I solve for k here? I would multiply both sides by 4. Multiply both sides by 4. 4 30s. 2 30s would be 60. 4 30s would be 120. 120 equals k. So now I can go back and write my equation, y equals 120 over x. 120 over x. Okay, so now we have our formula for this inverse variation. So now they want me to find x when y equals 150. So I'm going to put in the 150, and we're going to solve this for x. Now let's think carefully about what we have to do here. In order to solve for x, first I'm going to have to get x out of the denominator on that right-hand side by multiplying both sides by x. Now I have 150 times x equals 120, and I'm going to divide to solve, dividing by 150 to get x alone. And x equals 120 over 150 would be 12 over 15. Divide both of those by 3, we get 4 over 5. 4 over 5. So that's how you'll solve a simple inverse variation problem. Okay, now, identifying whether we have a direct or an inverse variation, or neither, as the case may be. So let's take a look at the tables of ordered pairs, and you ask yourself, what's going on? Well, you're going to check one of two things, or both of two things, okay, in order. You're going to start with, is it direct? If it was direct, then that constant k would be the ratio of y to x. Y to x. So let's do that. Let's find the ratio of y to x for each of these. So that's 1.5 to 0.5. That's 3. Okay? Is that the same as 6 to 2? That is also 3. So we're good so far. Is that the same as 18 to 6? Yes, they're all 3. So yes, this is a direct variation. And we know that because the ratio of y to x is what is staying constant. That means our equation for this direct variation is y equals 3x. Okay, we didn't have any need to check anything else, but we would start with that. excuse me, if it's an inverse variation, what stays constant for an inverse variation? Well, remember we had y equals k over x, and you would multiply it to solve. It's x times y. It's the product of x and y that stays constant in an inverse variation. So let's again start with our ratio y to x. 3.2 over 2 is 1.6. 1.6 over 4, they are not equal. This is 1.6. This one right here is 0.4. And those are definitely not equal. So this is not direct. So let's check the other possibility, which is x times y. 2 times 3.2, that's 6.4. 4 times 1.6, that is also 6.4. Is that equal to 6 times 1.1, which is 6.6? No, it is not. This is 6.4, or 6 4/10. This is 6 4/10, but this last product is not 6 4/10. It's 6 6/10. So this is not direct. Okay, it wasn't direct. It's not inverse. So this one is a neither situation. This one is neither. Okay, let's try one more of those. Okay, so one more of these. Inverse or direct or neither. So again, we're going to start off with the ratio of y to x. So 0.9 to 0.8, 9/8. Is that the same thing as 1.2 to 0.6? It is not, because that second ratio is 2. So this is not direct. Is it inverse? Find the product of x and y. The product of x and y. Because remember, if y equals k over x, and we solve for k, we would multiply by x, and x times y would equal k, which remember is k for constant, and that's what remains constant, so that's what we're going to check. So 9/10 times 8/10, or 8/10 times 9/10, 72/100, check. All right, 6/10 times 1 2/10, 72/100, so far we're good. And is that going to be equal to the third one, which is 4/10 times 1 8/10? Yup, 72/100, so that one works. And because that ratio is the one that's the same, excuse me, that product is what's the same, that's our equation. It's 0.72 over x. And that's the equation for this, and this is an inverse variation. And we'll have a couple more of those towards the end of the video for you to try on your own, and then we'll go over them like we always do in our videos. Okay, moving forward. All right, so the graphs of direct and inverse variations. They each have a pretty distinct shape. We looked at the graph of a direct variation in class. We graphed several, I think 3, in class for classwork. And your graphs should have been only in quadrants 1 and 3, or 2 and 4 for the direct variation graph where k was negative. And so you get a linear graph. So the graph of a direct variation is linear. Whoa, hold on. Sorry about that, forgot to change my pen size. The graph of a direct variation is linear. As we said in class before, it always passes through the ordered pair 0, 0. And other than that, remember that if you have 2 points that are on that direct variation, you've got your line. All you have to do is plot 0, 0 and your one other point, draw your line, and you're good. The graph of an inverse variation is called a hyperbola. Hyperbola. And we're only looking at the first quadrant, but if I was to continue and graph the other quadrants as well, you would have a graph, the rest of your graph would be a mirror image of this, what you see here, this curve, reflected over the origin. And so that's called a hyperbola. And that hyperbola graph will never pass through 0, 0. Will never ever pass through 0, 0 at all. Because there is no way that you could have 0 for an x value. Let's think about that real quick looking at this equation. 0 in a denominator, not allowed. Undefined, not okay. Mathematically illegal, if you will. So an inverse variation graph is a hyperbola. A direct variation graph is linear. Okay, continue. So if they give me a problem and they tell me the relationship between x and y, and that's what they have here, let's read it. When x is 2, y is 4, find an equation that relates x and y in each case. So we already did this. X and y vary directly. This is the first one where x and y varies directly. As we learned, the ratio of y to x is what stays constant. So we take the y and the x they give us, We plug them in, we divide, and now we have k. And our answer is going to be written as an equation, y equals, plug in your k, times x. Y equals 2x, and that is the equation for this direct variation. Let's look at the same problem, but where x and y vary inversely. And that's what we have here. When x is 2 and y is 4, find an equation where x and y vary inversely. Now, we said earlier, remember it's y equals k over x, and we said earlier if I solve that for k like I did with direct, I'm multiplying by x, and that means that results in xy equals k. So it's the product of x and y that stays constant. So if they give me x and y, I'm just going to plug them in and multiply them, and you have 8. 8 is the product of x and y. So when I go back to write my equation, it's y equals k over x, and that's the equation for this inverse variation. All right, so we'll see some more problems like that in class. Okay, so let's do some more practice with direct or inverse variation. So what I'd like you to do is to pause the video. Yes, it would be a good idea if you copy down the tables. Stop whining about it, please, because how exactly do you plan to know what it was that you were doing in the first place when you look back at your notes? But I'm going to pause it. I'm going to write it out, and then we'll go through the answers together once I've written it out. So please pause it and try this for yourself. Okay, so immediately after this, the answers will appear. Ta-da! There we have it. Okay, let's go through it together. Here's our table. If it's direct, we want the ratio of y to x to stay constant. If it's inverse, we want the product of x and y to stay constant. So I started each one by checking to see if it was direct, by finding y over x, and then finding the next y over x. And in this case, very quickly, we saw no. It is not constant. This is not a direct variation, so I moved to inverse. So again, we're looking at the product of x and y. So I plugged each of these products into my calculator, and every one of them gives a product of 3/10. So since that's constant, the product is constant, that's an inverse variation. Now I go back. That constant product is the value of k. That 0.3, that is k. So we go back and we can plug it right in. Y equals k over x. Second one, direct. Y over x, 2. Y over x, 2. Y over x, 2, and y over x, 2. Constant of variation is 2, and we plug it in. Y equals the constant times x for a direct variation. The third one also turned out to be a direct variation. We didn't have any problems that turned out to be a neither problem. Okay, last part of this video, we're going to look at a couple of word problems. Okay, here are our 2 word problems. The blue one is direct, the red one is inverse. Let's jump in, get this done. The weight of an iguana is directly proportional to its length. So I'm going to write an equation for that right off the bat. If y varies directly with x, this is telling me weight varies directly with length. So that's my equation. In order to find k, I'm going to plug in the values I know. I know that a 30-pound iguana has a length of 4 feet. A 30-pound iguana weighs 30 pounds, but has a length of 4 feet. So let's solve this for k by dividing by 4. 30 over 4 is 15 halves, which I'm going to leave 15 halves for the purposes of my equation. So 15 halves times the length. And now I know that I'm talking about a 5-foot iguana. So in order to find the weight of that 5-foot iguana, we're going to plug in 5 for the length of the iguana. And when we go ahead and multiply, remember, fraction times whole number is numerator times whole number, 75 halves. Now, you don't walk into the vet and say, Iggy here, Iggy my iguana weighs 75 halves pounds. No, you don't. You say it usually probably in the form of a decimal or maybe a mixed number. So what does Iggy the iguana weigh? He weighs 37.5 or 37.5 pounds. Now, there is a way to do this with a proportion as well. If that's what you did when you started, for those of you who like to pause and try it yourself, that's excellent as long as you got 37.5 pounds. We'll talk more about using proportions for those in class. The next one is our inverse. The time it takes to make a trip varies inversely with the speed of the car. So again, inverse variation is y varies inversely with x. So the time it takes varies inversely with the speed of the car. So let's plug in our numbers. It takes 9.5 hours, so that's t, when you go 40 miles an hour. So now we've got to solve for k. So I'm solving for k. I'm going to multiply both sides by 40. That leaves me 380 equals k. So my formula for this problem, my equation that makes this a problem, that describes this problem is, it's not y. Let me fix that. It's t. T equals 380 over s. And that 380 actually has a very certain significance for this problem. That's actually the distance that you're traveling in the problem. Okay, so how long is it going to take me to get there if I go at 50, an average of 50 miles an hour? Well, divide them both by 10. I have 38/5. And again, I'm not going to say, wow, I'm exhausted. It took me 38/5 hours to get here. No, instead you would actually divide it. Comes out to be 7.6 hours, which is 7 hours, 36 minutes. Okay, the last conversion is just something I did for you so you could see what is 0.6 hours. Well, it's 36 minutes. And again, there are other ways to do these problems. We'll talk about them in class, but this is the most straightforward way based on what we've learned. This video is getting a little lengthy, so I'm going to go ahead and call it quits. Thank you for watching. Go back and take good notes if you didn't. I will see you in class.